it's a very efficient way of getting all the information from across the whole field in a week. So just for general education, to see what's hot, what's new, what the group maybe should be doing next. Also how some of the stuff that we're doing is viewed internationally. What's the real profile of things that I think are important from a UCL or a British point of view. So I was going to come anyway, but actually, of course, this time I'm giving a presentation on the Eurostar paper. This is the place to come and advertise new stuff.
Ordinarily, I would come to a conference like this to want to talk about what we've done, rather than sort of make it possible for other people to talk about what they've done. But because Penn and Princeton decided to host this, and we discovered, being amateurs, that there's more work involved than we had planned, we recruit everybody who should be doing other things to help keep this from being a disaster. So yeah, no, this is not my day job. This is something that will be very nice to get passed next week.
It's clearly much more economical than the standard gauge mediation model. And we would like to ask, do these models give any clear predictions?
These results, if you can compute them, you can add up the systematics and the luminosity.
To do all of these things, you of course need high precision predictions for a single...
I've given a similar talk in the UK, so it wasn't a huge amount of work to write the talk. It's more a matter of removing the private atlas bits and a little bit of the jargon and making it a bit more general, but fingers crossed. I'll go through it another couple of times probably this evening, and I'll probably find things I'm not happy with it, but I'll probably leave the slides alone now and just try and work on my spiel.
We can predict beta and MQ and fit beta and MQ into this equation for doubly heavy barrel.
I cannot tell from the bits because I don't know what the bits are.
It doesn't matter, it's a difference.
I don't know if it's muons, it should not be affected by the calorimeter, right?
No,
I think the one that you're actually using.
Algorithm.
The noise comes in here. You want to isolate so this knocks out some noise, but none of the noise here can get into the next part.
Science is done by people, and people can get interested in things and they can get uninterested in things, or they can get new ideas, and talking to people is more fruitful for doing that sometimes than just reading about what somebody has done. Because then somebody says, well, what if? Or did you think of this?
So how do we identify these Higgs candidates? Well, first of all, they're very collimated, so typically for most sensible radii of jet finders or most sensible jet algorithms, you find all the Higgs decay products in a single jet. The scale in a jet that contains a Higgs is actually set by the Higgs mass, not by this QCD strong ordering. So what that means in the end is if you're used to thinking inside a single jet, and we have to start looking at how we unpick these jets and do physics with them. That's all.
For 15 minutes, we come back at 10:30.
So the tagging is not, in my opinion, still well established until the efficiency and the rejection power.
Yeah.
And in your case, it's even more difficult since you are more constrained. So I don't know. I think what you propose is new.
Yeah, that's right. We have to look.
It's interesting to pursue.
Carl Jacobs has a student who's been looking at this and has done a study within.
Carl is a very serious person.
Yeah.
So
Somebody who didn't want to spend their money to come here can see every slide a few hours after it's presented. Isn't quite the same. The conversations are the real value.
Well, I think, as you were saying in Bern, I think we have to make the local hadron calibration. It has to work at some point. I mean, at least at some level, at some point soon, it has to work, because I really think that, well, we're going to have to look we're going to run many different algorithms, and we're going to have to look inside the jets. You'll always need some kind of afterburner for each, in the end, for the analysis. But just to be able to do scans with different jet algorithms and different current radii and things like this, I think we should.
Much of the real work occurs in these little side conferences you see. The three people huddled around the coffee table sketching something on a napkin might be planning lunch, but they might also be planning the next breakthrough detector.
If we go 3-tag to 3-tag, then we think we've taken out some of the statistical variance. But then we have an effect that is a few sigma.
Right, so
the argument...
are we going to show just a few sigma difference? I think the first way should be good.
Yeah, but you still have the problem that what I told you, that a priori in the perfect states it's completely Lorentz invariant. You're not seeing it. And I think you must perturb it. This is the thing. First you perturb it, and then you can probe it with interferometry. That may be a good thing.
Perturbing, that's very
That's the
interesting.
problem.
Yeah.
So I gave my talk today. It was fine. What have you been up to? Did you go to your summer school thing again, Leon? Yeah, thanks. Ta-ta, baby. Ta-ta. The technology's fine, it's the family that are the problem. It's significant that the big milestone in the Eurostar thing was when we published. The intellectual property of the whole thing is kind of staked by the fact that you've produced a paper with your name on, and then you really want to talk about that formally and informally as often as possible with people working in the same area. If you don't have those kind of interactions, then you don't get the next idea. But the ideas, when they're out there, are the property of the human race in some kind of ideological sense, and that's fantastic because then anyone can pick that idea up and can contribute to it, follow it on, show that it was a bad idea, improve it, all those things, and that's what science is about.
Collimated beam and then maybe losing 90% of it, but still have 10% accelerated to high energies.
Well, unfortunately, the plasma people don't speak the language of these things.
My laser friend says, okay, forget about it, it will be laser driven.
But the laser people have their own, their own ideals, shall we say.
You need to look at nature a lot, and we're looking at it in a particular way, which is not really the same way that an artist looks at it, I guess. And we're describing it in mathematical language and things, which is quite formal and quite rigid. And I think all physicists have pictures in their head, at least certainly I do, and I think most of the people I've worked with do. Have pictures in your head that are kind of based on the mathematics, and but with only the maths it doesn't work for me. You have to have a picture of what's going on, and sometimes your picture's misleading, sometimes it leads you to new insights. It's not freeform, you are constrained by what we know nature does and by the maths that we use to describe it. But within that structure there's an awful lot of creativity required. In a way, I guess, if you look in art, people often set themselves formal frameworks within which they can be creative. And often you get the best creative results from people responding to a constraint that nature has imposed on them or that they've imposed on themselves. And you know, those moments when you get a great idea or a great insight are really what it's all about.